the velocity is the same as the derivative of position.
Okay.
And they're related. And then they can sometimes give you a function here. And you would normally go ahead and graph this. Do you think you'll be expected to graph something like this by hand? This one's somewhat complicated. Let me just snip in a graph of it.
I don't know, honestly. I could ask him tomorrow.
Usually it's a quadratic that's factorable, and you got to find zeros and a few other things. But let me just graph this and see if I can detect anything. And we're doing this from 0 to 5. Okay. So the short of it is that it's a graph that looks like this. And this point right here is estimated to be 1.26. We can find it exactly if we really needed to, but let's just go with this for the moment here. I can ask you things like,
sorry, how did you get the 1.26? You just put that in your graphing calculator?
Yes, okay. I didn't do anything. Gotcha. I didn't do anything special. If we did want to find it, we would set the whole thing equal to 0. And that requires a fair bit of effort to solve, which I don't think you would be expected to do. It's out of scope, I guess what I'm saying.
Okay.
So now that you have this graph on the right, I can ask you things like, where is the velocity greater than 0? Where is the velocity less than 0? Greater than 0 means it's above the x-axis, or in this case, the t-axis. And then less than 0 is when it's below the x-axis. So it's above the x-axis from 1.26 to 5. I stop at 5 because the problem says it only goes to 5. And actually, I need actually, it's an open one here. Below the x-axis is from 0 to 1.26.
Okay.
And then the only place where velocity equals 0 is at 1.26. Yes. Okay. Now, if I were to create some shapes here and regions, and then I fill them in, I'm going to fill in the first one with red, and then the other one with green. And I'm just connecting these with the so the green represents like forward motion, we'll say, or like moving away from home, as I sometimes call it. And this other one is like moving away. And so like you can think of this as negative, contributes negatively, and then it contributes, the green contributes positively.
Okay.
This is all review. This is all, there's nothing, this is nothing new here, except it maybe you haven't seen it in a while.
Yeah.
Okay, so where we can finally make some sort of a calculus statement that you might be interested in is there's distance, and then there's displacement. Do you remember these?
Yeah.
These words? So displacement is how far from where you started. So it's literally the integral from in this case, 0 to 5, v of t dt.
Okay.
But distance doesn't want you to like add and subtract. Everything is now positive. So the displacement would take the red area and call it negative, and the green area and call it positive, and add them together. And I don't know what it would be, but it's close to 0, we'll say, roughly.
Okay.
Whereas the distance is...
Is it just 1.26 to 5?
No, well, it's so more generally, it's the absolute value of v of t.
Oh.
Okay. And how do you actually, and so this only works when you're using a calculator. When you actually have to do this by hand, you have to figure out where v of t equals 0, which we know is at 1.26. So kind of based on what you were saying, I think you kind of understand this is there's two integrals, one from 0 to 1.26 v of t, And then there's an integral from 1.26 to 5 v of t. Okay. Which of these is positive? Is it the one from 0 to 1.26 or the one from 1.26 to 5?
1.26 to 5.
Okay. So we know that this one's gonna be positive on the right, but this other one's gonna be negative. So we put a negative in front so that the area becomes positive.
Okay.
So as a reminder here, I'll give you a couple examples here. If you're on a track and you go all the way around, your distance is all the way around. But if you get back to where you started, your displacement is 0. But your distance is all the way around.
Well, so the distance is all the way around and the displacement is
0 if you get back to where you started.
Because it's adding the negative and the positive.
Yes, like it's counting forwards and backwards. Like maybe you went on an airplane and on your break, but you've been on airplane before. You go from Tucson to somewhere, right? And then you get back. Well, your displacement is 0.
Oh, because you ended up at the same place. I see.
Right, but your distance is however far you went, 2 times the trip, basically.
Got it. Okay.
So because one way counts positively and one way counts negatively, that's why you have to take the absolute value to get it.
Okay.
So let's try a simpler example here, because your instructor had the reasons for choosing this. Let's say your velocity is t minus 2 from 0 less than or equal to t less than or equal to 4. Okay, so if I just asked you to integrate v of t from 0 to 4, is this distance or displacement?
Distance. No. No, wait.
It's easy to confuse the two. So the absolute value is distance.
Yes, it's displacement.
Displacement it doesn't take into account. So let's do this. It's the integral from 0 to 4 t minus 2 dt. So this equals 1/2 t squared minus 2t evaluated from 0 to 4. That's just taking your antiderivative. So it's 1/2 4 squared minus 2 times 4 minus 0, which is 8 minus 8, which is 0.
Okay, so you just did the okay, yeah.
Okay. So the antiderivative is the function over here on the right, and then you evaluate it at the upper and lower bounds.
Right. Okay.
If you want us to review any of that, just ask me, or I'll go through it a little shorter. But see how the answer is 0?
Yeah.
Let's look at why. So the graph of this looks like this. So this is -2, this is +2. So again, if I use those colors again, it's the area of the red, which contributes negatively, and the area of the green, which contributes positively. And they're exactly the same.
So they just cancel out. Okay.
Yes. All right, now what you're more likely to be asked is the distance. Like it's the same setup here. Let me grab this part of the problem. It's the same setup, but it would say, what is the total distance? And they don't even have to say total, but they can just say total distance from t equals 0 to 4. Okay, so this time it's
now you're using absolute value.
Yeah, and so like this is correct the way it's written, but or even you could sit here and say it's absolute value t minus 2 dt, and that's great, but your instructor wants a number, and that's why that's why you need to know where the breakpoint is. So the breakpoint is where it crosses the axis.
Okay. How do you know to, oh, never mind.
So the way that whatever you're given here, you have to set it equal to 0. So we'll do one a little more complicated than this, but like that's what you're doing. So then it really becomes two integrals, and don't try to decode absolute value. Just recognize, okay, it's the integral from 0 to 2, t minus 2 dt.
How do you know, like, to do 0 to 2 and 2 to 4?
You're looking at where it hits there, and then it's.
Oh, okay, gotcha.
So we're going to look at a problem next that looks like maybe something like this, and then you got to do 3 regions.
Oh, okay.
All right, so the way this works is, again, is you have to figure out, well, which one's positive. Well, the one on the right's positive, the one on the left is negative, so you negate it.
Yeah.
Okay, and then you got to find your antiderivative. So that's 1/2.
Yes, t squared over 2.
T squared minus 2t, value from 0 to 2. I would just deal with the negative at the end, like whatever you get here, put a negative, and then it's the same thing here.
That's
1/2 t squared.
1/2 of 4, so that's 2 minus 4 equals negative 2. So positive 2 on the left, right?
Okay.
And then 1/2 of 4 squared. 4 squared is 16, so that's 8 minus 8, and that's 0. But then it's the other one, so 1, 4. Oh, it's the same thing. So 0 minus 2. So negative 2, 2 minus 2, 0. The whole thing 0?
No, it can't be. So like, the reason I wasn't writing anything down is because, like, we know just from the picture. Sorry, this thing got stuck here. From the picture, we know it's the area of this triangle. Like the one on the left needs to be 2. So
yeah, I got 2 on the left.
But like inside here, it's somehow this was negative 2, hopefully.
Yeah.
Okay, so that's 2 plus, and then over here it's 1/2 4 squared minus 2 times 4 minus 1/2 2 squared minus 2 times 2. So 16, that's 8 minus 8, that's 0.
Yeah.
And then this one, 4 1/2 4 is 2, 2 minus 4, but then you negate it. So this becomes 2 as well.
Oh, I forgot to negate it. That's why.
Yeah.
Because I did 2 minus 2. So it's 4. Okay. So they would ask you for both the distance and the displacement on these?
Could be, or they could just ask for one or the other. So you should be prepared to do both.
Okay.
You'll notice that displacement is much easier because you just integrate it and you don't think very hard about where it hits or doesn't hit.
Okay.
All right, so let's try another one here. Let's say V of t. You had on your midterm something like this that was, or midterm review, it was something like this where whenever you factored it, you got t minus 1, t minus 3. So let's just expand. That would be t squared minus 4t plus 3. Okay, and let's just say we wanted to go from 0 to 4.
Mm-hmm.
Okay, so the graph of this looks like, and it is important. The more math you take, the more it's like you do want to get a picture of what's going on here. It has a 0 at 1, and then another one at 3. We don't necessarily care how far down it goes, but we want to make a rough sketch which shows that, hey, there's area, below, and then these other regions here. So let me just shade those in for us. Just that, and then all right, so now we want to find, if we wanted to find the displacement, we would integrate t squared minus 4t plus 3 from 0 to 4. Now I should be writing this down. This is displacement.
Okay.
Okay, so we should do that first.
So it's cubed over 3 minus 4t. No, wait. 2. Okay. So that's 4 to the third is 4 times 4 is 16. 16 times 4, 64. Over 3 minus 2 times 4 squared is 16. Plus 3 times 4, which is 12. 32 plus 12. 4. 64 over 3 minus 44. Does the right two side come out to 44? The like 2t squared plus 3t.
So it's the minus 32 plus 12.
Oh wait, it's minus 32. That's why.
Yeah.
Okay, so that's 20. Okay, so then you just put it over 3, so then that becomes 60, right? Yeah, so 4/3, right?
I mean, I'm looking at 4/3. Yes.
Okay.
That's right. Which means most of it. I mean, not most of it. Like it's pretty equal above and below.
Okay.
Okay. So now the next question would be like, what is, if this is part A, part B is, well, what is the total distance? And it's the same integral 0 to 4 with the absolute value, but you maybe write this way. Let me get the t squared minus 4t plus 3 dt. You might write this, but it ends up being 3 areas. And if that's not clear, we'll go back to the picture. It's this first area from 0 to 1, then from 1 to 3, and then from 3 to 4.
But haven't we done, why did we do the whole thing in 1 then above? Because we did it from 0 to 4, right? Yeah.
I asked for displacement.
Oh.
Right, so displacement means going forward and backwards. So try setting up the 3 integrals here. I'm just going to step away for 30 seconds, but I'll be right back.
Okay. How do you know the intervals? I got 0 to 1, but like if you don't have a picture, like
You have to set it equal to 0. So you would set t squared minus 4t plus 3 equal to 0. And then you would factor in this case, and you would get t equals 1 and t equals 3 as your zeros. And since those are between 0 and 1 or 0 and 4, that's how you know to include them. Like, let's say it was they were outside there, you just wouldn't care. But you do need to have some knowledge of the graph. Now, if you don't know whether it's positive or negative, like we can answer that question in another problem by just testing points also.
So then it's the other one is 1 to 3, and then the last one's 3 to 4.
Yep. So a lot of writing here, but the middle one is actually negative because it's below the x-axis.
Okay.
And that's the whole point here is you turn negative areas positive, you keep positive areas positive.
Gotcha. So that it's t cubed, it's the same thing over 3 minus 4t, or no, 2t squared plus 3t 1 0. So then that's 1/3 minus 2 plus 3 minus 2 plus 3 is 1. So 1/3 minus 1.
No. It's 1/3 plus 1.
Yeah.
So it's 4/3.
It's 3. Yep.
Okay. Keep in mind that when you evaluated it at 1, you got 4/3 because that becomes really critical here. So you don't have to redo the calculations over and over.
Right. Okay. So then you just got to do it for 3.
Yeah,
so
it's the same antiderivative.
Yeah. So then it's just 3. Oh wait, 3 times 3 is 9. 9 times 3 is 27. 27 over 3 is 9. Minus 2 times 9. 3 times 3. Is it 0?
It's 9 minus 18 plus 27. Did you get to that point?
27.
Oh, I'm sorry. This is wrong. It's 9. Yes.
Yeah. Okay.
Okay. So that part is 0 minus 4/3, but then there's a negative out in front, so it's plus 4/3.
Okay.
A lot of signs to keep track of.
You already
now this is important though, is that this left side 3 was 0 because you're going to use that in the next one, and
so you just have to do 4 now. So then that was 64 over 3. Wait, didn't we already do 4 up top though?
We did, yeah. So you can always go back and look for it.
What did that turn out to be? I don't want to do it.
Yeah, I know what you mean. It's
So then it's,
I think it ended up being 4/3, but then you subtract 4/3 because that's the right hand side, so it becomes 0.
So it's 4/3 plus 4/3. So then that's 8/3.
Yeah, there's something not right about this, but it was no, it's minus 0. Sorry, not 4/3. This is also because the area can't be 0. When you evaluate 3, it's 0. So
and it's plus another 4/3. So then that's 12/3, which is 4.
Yes. So this one just so happened to be the same area each time, but that is not even close to a reasonable expectation for these. Okay, let's go back to the notes that you sent me for 8.1. Let me get you to look at this graph and kind of do the same thing, because you could get the same question with a graph. These are on the AP. So if you have changed your mind about taking it, I mean, these are really common questions to get on there. So this is the velocity. Oops, velocity, and this is time. Okay, so I could ask you part A, and then I'm probably resize this, but A could be, what is the displacement from t equals 0 to really anything, but let's go t equals 8. So in that case, the area up here is positive. and then the area below is negative, and they work against each other. And since it's a triangle, and a trapezoid, you can find the area of each shape.
Okay.
So for here, there is no like antiderivative. It's just graphical.
Could you
things.
do like for the left one? Could you do like two triangles and a
Yes.
rectangle?
Yes.
Okay.
So let's do that here.
Or I guess first, you could do the trapezoid, whatever.
Well, if you don't remember the formula, you don't want to take a chance. Just make it.
That's right.
Now, if you're gonna do that, I mean, why not just take the triangle and flip it up over here and make it into a rectangle? But anyway, let's just
Wait, why would you do that?
Just to keep from having to do a triangle. But let's.
Oh, I see.
We'll just do it this way. So it's 1/2 base times height. So this one on the left here is an area of 2. Sometimes it's good to even write it in there. This middle one is
1 times
4.
4, yeah.
And then this other one, it's 1/2 base, which is 1, height is 4, so it's also 2.
Yeah, so the whole thing is 8.
Yes. So it's 8 plus, well, actually minus, because
it's below.
Now, again, 1/2 base, your base is 2, your height is 4. You could tell me that the height is -4 because it's going down, but we've already accounted for it over here. So just treat it as if it's an upside down triangle. So that's 4 for that.
Wait, but don't you have to do two of those because it's like split in half?
I'm just doing this long. This part is the base and then the height. You could do that, but they're the same. Here, this third one, that's kind of the power of this method is it's 2 right triangles, or you just take 1/2 the base, which is 3, and the height is 4.
Yeah, okay.
And you get 6. So it's 8 minus 4 plus 6 equals 10. Hooray. Okay, got that.
Cool.
Part B, let's say, what is the distance?
So no negative.
Right. So wherever you had a negative, it would be 8 plus 4 plus 6.
So 18.
Yes. And because this is a application problem, they didn't give you any units in here, but let's just say it was like meters per second. Your answer needs to have meters in it, or feet, or whatever the units are when you're doing this problem.
Okay.
Okay, so one other thing here to talk about. So if I ask you, this is just more general. If I say, well, the integral v of t from a to b dt, and we know that v of t is the derivative of position. So you start out with a position function, you take its derivative, and that's the velocity. And that's what we're integrating here. On the left, we've done a bunch of these problems. This equals, and you've already done this, s of b minus s of a.
S of b?
Yeah, that's the position function.
Oh.
It's the antiderivative. Okay, so it's like, this is the summary of what we've been doing. Not sure if seeing it now helps or not.
Okay.
All right, do you remember the swimming pool problem?
Oh, it was like a worksheet. I don't have it with me, but I don't really remember what it was. Okay. So we could go, if we've done everything in 8.1, we could go to 8.2.
Let's do, there's just one more little thing here to talk about, some questions here. It's kind of related to this last discussion. So again, like if you have a position function, when you take the derivative of the position function, that's your velocity function. And when you take the derivative of that, so it's the second derivative, it's the acceleration function. Now, instead of using S double prime, you would say A of t. Instead of S prime of t, you would use V of t. These are just shorthands that we know. So when we look at this question from your class here, where it says, okay, a car with an initial velocity of 5 meters per second, sorry, miles per hour, accelerates according to this function. How fast is the car going when the 8 seconds are up? So do you want to do this type of question here? Do you think this will be on the test?
Yeah, we should probably do it.
Okay. So they're giving you the acceleration function. If you integrate acceleration, that's like going backwards. Do you see that you get velocity from that?
Mm-hmm. Yeah.
Okay. So we're going to integrate this function. We're going to integrate 2.4t. Okay. And the dt. And then the question is, well, what are our bounds? Well, it's kind of an initial value problem. So let's just take the antiderivative here. It's 1.2 t squared plus c is v of t. Do you kind of see that power rule on that one?
Yeah.
Okay. Now it says it has an initial velocity of 5 miles per hour. Oh, this has got the wrong units. I wonder if instructor meant that.
Yeah, I remember him. He was like, you have to switch or whatever.
Okay. Yeah, so like the functions in miles per hour, and this is fine. So right, this function's in miles per hour at the moment. We can convert it later if we need to. So the initial velocity at time 0 is 5. So when t equals 0, v of t equals 5. So we have 5 equals 1.2 0 squared plus c. If you remember in the last problem, we did a bunch of those where they're called initial value problems, where you find the constant integration. So c is 5. So your v of t is 1.2 t squared plus 5 miles per hour.
Okay.
Now we can actually ask the question where it says, how fast is the car going when the 8 seconds are up?
So is 8 your t?
8 is t, but t is in the wrong units. We have to convert t to hours.
Right. So you have to multiply by.
Well, there's 60 seconds and 1 minute and 60 minutes and 1 hour. It's a division problem. It seems really wrong, but look, try and look at the notes. They're kind of hard to see.
Yeah, sorry, it's because like a picture.
So your instructor just put 8 in, which I don't quite agree with because the way this is written. But
wait, just put 8 in where?
Well, he doesn't convert it to hours.
Oh, I think he does at the end. Wait, no, you're wrong. You're right. I mean,
I am wrong. I do see a conversion there. So this sometimes happens when instructors try to mix, physics with math and other things. I'm just going to defer to whatever's there because I don't think I'm going to help by trying to figure out what was intended here.
Okay.
It does say units conflict miles per hour and seconds. I mean, the way to make this problem more clear is to just say it's meters per second, and then you don't have any problems here. But what I want to make sure you understood is this part, and I think you do, that the antiderivative of acceleration is velocity, and similarly, if you go backwards from velocity, you get position.
Yeah.
Like this isn't necessarily a reference, but it's like a thing to really keep in mind. Okay, let's look at 8.2. Hopefully there's more here. Yeah, there's way more here. Okay.
Yeah.
All right. Let's look at, I'm just going to start with this first problem that's given. on the sheet here. So the starter problems for this section, they actually tell you where the curves intersect. And then the more difficult ones like this one, you have to figure that out yourself. Okay, so the step one is to literally figure out where do they equal each other. So you set 4 minus x squared equal to x squared minus 4. And yeah, if you have a graphing thing, you just click on it, but you won't on your exam. So let's review. Generally, you want to move the x squareds to one side. So if I add x squared to both sides, then add 4 to both sides, and then switch, you get 2x squared equals 8.
Wait, -4 plus 4 though.
Those cancel.
Oh wait, I see.
And it makes 8, and then I flip sides.
I see.
Okay, and so that equals 4, but then you got to remember that it's plus or minus the square root of 4 plus or minus 2. So that tells you -2, +2.
Yep.
And then more generally, you're doing the integral from a to b, top minus bottom. So you got to figure out which one is the top one and which one's the bottom one. To do that, there's a couple of ways you could try to work through that. One is to recognize that this one opens up, the x squared minus 4, and the other one opens down, which gives you a pretty good indicator. You could also try a value between the two of them, like 0, and figure out where each one is.
Okay.
Like 0 squared minus 4 is -4, and then 4 minus 0 squared is 4, so that obviously is on top.
Wait, but why can't you just do it from -2 to 2?
No, you are, but the top minus bottom refers to your curves.
Oh.
Okay, so let me try and show you what the two possibilities are.
Okay.
So if you're not paying attention, so this on the left is correct, is 4 minus x squared minus x squared minus 4. This is correct, but you could, as a student, very easily write it the other way.
The x squared and okay.
Now,
wait, so you just know that from the graph which one goes in front?
Yes, but I was also suggesting, like, if you're not sure, you could test a point between the 2 points.
And then see which one.
Yeah, is bigger or smaller, the y value.
Gotcha.
Now, in full disclosure, if you do the one on the right, you just get the negative of the area.
Oh.
And so if you just negate it and pretend like you understood, you could still get full credit. They probably will mark you out, but try not to do that.
I'm sure that'll be a multiple choice option, the negative version of it.
Right. Now you do want to like rewrite here. So do a little simplifying. 4 minus x squared minus x squared plus 4. This becomes 8 minus 2x squared. If things cancel, really check that you included your signs, because if you integrate the wrong function, you will never get the right answer. So really pay attention to that here. So that's the integral of that. Your antiderivative is 8x minus 2/3 x cubed from -2 to 2 now. So this is 8 times 2 minus 2/3 times 2 cubed minus 8 times -2 minus 2/3 -2 cubed, 16 minus 16 over 3. Okay. Plus 16.
Oh goodness. Fractions. Okay, so then 16 minus 16/3 is.
So I would do it this way. You've got two whole numbers here, 32.
Yeah.
And then I would put that over 3. So it becomes 96 over 3. Because they're
minus 16. So then that's.
But there's 2 of them, so it's 32 over 3, which gives you 64 over 3.
Okay. It's just the fractions. It takes so much work.
Yeah, they're awful. They're awful. So let's do the next one, next example.
Okay.
the reason you're learning this topic is for an upcoming one on finding volumes.
Oh.
It comes back. It's not, they aren't as complicated as this, but the idea is important. So notice again, it just says find the area enclosed by the two curves.
Oh, is it the disk thing?
Disk, yeah, disk.
Yeah, we started doing that today.
Okay. This one, it doesn't tell you, like sometimes it actually does tell you from like 1 to 3, and then you don't have to do the thing that we were doing, which is figure out where they're equal.
Okay.
But since we don't know where they're equal, you have to find this. Okay. And if we move everything to the right, if we add x squared to both sides, subtract 2, we would get 0 equals x squared minus x minus 2. And when you factor that, you get x equals 2, x equals minus 1. So those are the bounds of your integral. But it's top minus bottom. And that's where it's tough. Like you probably think that you probably know that one's on top because it opens down and then this line cuts through it. Again, if you get the wrong answer, it's usually just negative of the right answer.
But isn't the, oh, but is it because of that like little sliver that the?
Yeah, sorry, that's not a good picture. It looks something like this, and then it gets cut kind of like
Oh, I see. So okay. So even if it's like a small part is on top, that's still.
Yeah.
Gotcha.
Minus a minus x. You'll notice I always show them in parentheses because there is the possibility that you're going to distribute.
Right.
For clarity, also, it just helps.
So then you do the antiderivative of that?
I would distribute the signs and then find the antiderivative.
Okay. So 2x.
There's also some value in actually rewriting it in descending order. But that's up to you if you want to do that.
Okay.
It's not mandatory, I guess.
So then it's negative, or it's 2. So 2 minus 2 cubed over 3 plus 2 squared. 4 minus 8/3. 8 minus. Isn't it? Isn't it 4? Oh wait, 1/2.
I'll write it out here.
Why did I get? Isn't it 2x squared over 2? Oh, I forgot the over 2. That's why. So then that's 2. 6 minus 8/3. Okay.
Are you comfortable with these numbers? Like,
yeah.
Okay. So you got to do these in pieces. Like this is 6, but 6 is really 18/3. So you combine them to make 10/3. And then inside here, this is awful. I guess I would probably
make all 6.
I guess, yeah, it's not good. It's not good. It's 2 6 plus 3 6 minus 12 6.
So then that's 5 minus 12, which is what?
Minus 7. And then it negates here, so it's plus 7 over 6.
And then you have to do that. So then that's, wait, so times 2, 20. Yeah.
Now this is not the same as what you have in your notes. So someone's off here. Let me look. Let me try this. Did I get the right bounds?
Negative.
-1 to 2.
Yeah.
So let's see here. It's 2 minus x squared plus x.
Maybe the negative the 1 is. Oh, isn't it because it's -1 minus 2? Isn't it? Shouldn't we have done it the opposite way?
These are okay. I mean, the
No, but
bottom
like
one.
when we did the antiderivative, doesn't it have to be the? Oh no, it's top minus bottom, right?
Yes.
Okay, wait. So that's wrong.
I use Wolfram Alpha to do integrals like this when I'm checking, and it's not that bad, but this one isn't giving me any. Their engine must be full of people finding integrals like this. Come on.
Maybe we did.
The antiderivative in your notes is good.
Yeah. So maybe it's just the calculation part.
Yeah.
So -2/3 over 3 plus 1/2 of 2 squared.
Let me go find one more calculator and see if I can get you a better answer than this.
1 squared.
Definite integrals. -1 to 2. Then we said 2 minus x squared plus x. Is that right? Yeah. Yeah, it is 9/2. So there's
Did we do? Can you scroll down a little?
Yes.
Isn't it +2 because it's like from that line below?
I didn't change the sign until the end.
Right, but shouldn't it be all negative on that side? On the line below.
So it's -8/3 plus 2 plus 4. Is that
Yeah,
okay?
but here, but then don't you distribute the negative?
I was holding off on, I was like figuring this out and then distributing it. So I was like, okay, this is -1 cubed, that's -1, then a negative makes it +1/3. Then this is +1 1/2, this is -2. So we combine all these 2 6 3 6 5 minus. Yeah, there's some sort of a sign error here.
Okay.
I apologize.
That's okay.
Someone will watch this video at some point, a million years maybe, and be like, oh yeah, how come we couldn't figure this out? But who knows? But let's close out our lesson for today.
Sure.
Can I just really quickly ask you about schedule? I'm just going to stop sharing real quick.
Yep.